Solving system equations by graphing. So we're going to solve a system of equations. And what that is just a set of two or more equations that use the same variables. That makes it a system of equations. Now we're particularly going to be doing linear systems, which just means the system is a line, like all the equations are a line. So that means they have no power bigger than 1. So we're going to be doing stuff like y equals 3x plus 2, or 4x minus 2y equals 7, right? All the highest power you see is 1. Those are linear. So these are lines. So that's what we're going to solve. And then we're going to particularly do it by graphing. So how do we do it? Is we graph both of them. We're going to graph both our lines. So here will be like line 1, here will be like line 2. And the key is the solution is where they intersect, if they intersect, right? Solution of the system is where the lines intersect. So like in this example here, where we have two lines that intersect, they would cross right there. And that looks like that would be 2 and 3. And that would be a solution to the system. So to solve a system equation, we're just going to graph them. And if they intersect, that intersection point is their solution. So the point 2, 3. So that's one outcome of graphing two lines. So one outcome, we can have intersecting lines. The other thing is, what if they're the same line? Like you graph them, they're the same exact line. Well, in that case, we have infinitely many solutions. That's what happens when we have infinitely many solutions, or all real numbers. And then you can also have the case where they don't cross at all. They're parallel lines, and that's when they have no solution. So parallel lines have no solution. If they're the exact same line, they have infinitely many solutions. And if they intersect at exactly one point, that's your one solution. So how can you tell just by giving the equation? Well, when they intersect, they have different slopes. So if they have different slopes, they're going to intersect. Now, honestly, y-intercept doesn't matter. Does not matter. As long as they have different slopes, they're going to intersect. Now, when they're the same line, well, the slope is going to be the same because they're the same line. And the y-intercept is going to be the same because, again, they are the same line. Parallel lines, by definition, parallel lines have the same slope. So if you have the same slope, but parallel lines are going to have a different y-intercept. So that's the idea. So if you have like two equations and you notice that they have different slopes, they're going to intersect. They're going to cross. You're going to have intersecting lines. If they're the same everything, same slope, same y-intercept, now you might have to do some math to see this, but that's for your infinite solutions. And then we have parallel lines. You're going to have the same slope, but you have a different y-intercept. So if they have the same y-intercept, they'll be the same line. But parallel lines have the same slope, but different y-intercept. So let's do an example real quick. So we're going to solve this by graphing. So all we're going to do is graph each one. So I'm going to graph the first one in blue. My y-intercept is 3, so we're going to start at 3. My slope is -1, so I'm going to make it a fraction, 1/1. Remember, it is rise over run. So in this case, I'm going to go down on my y, and I'm going to go right on my x. So we're going to start on the y-intercept of 3, then from there we're going to go down 1 and right 1. So right there, down 1, right 1, and we get this graph right here. So that's the first one. Now let's graph the second one. So here my y-intercept is -2. And my slope is 3/2, so it's positive. We're going to go up and right. We're going to rise and go right 2. So from this point here, we're going to go up 3 and then right 2. And you can kind of see where they cross naturally here. And where they cross is my solution. And you do need both points, so 2, 1. Answer here is 2, 1. So it's like that. Now, sometimes it's not all nice in slope-intercept form like this one here. If you notice, it's still a linear equation, but they're not in slope-intercept form. So step 1, put in slope-intercept form. Put in y equals mx plus b form. So we gotta get y by itself. In this first one here, not too bad. Let's just subtract 3x from both sides. And we're gonna get y equals -3x plus 5. 5 minus 3x, same thing, but most of the time we like to put the x in front. So now I know my y-intercept is 5. And my slope is -3/1, right? Always make it a fraction if you can. So I'm gonna go down 3 and right 1. So from here, go down 3, right 1. So right there. Let's do it again this way I have it. Down 3, right 1. I'm gonna keep on going as long as I want. So there we go. Okay, I have to graph the other one. So this one, let's do that in blue, dark blue, I guess. Again, I gotta get the y by itself. So a couple choices here. Let's subtract the x from both sides. Probably the most people are going to do. So we have negative y equals negative x plus 7. Right, we minus x from both sides. These cancel. I have 7 minus x. I'm just going to write the x first. Negative x plus 7. But I still have a negative y. Remember, you don't want a negative y. You want the y by itself. So we're going to divide. You're going to either flip all the signs or we're going to divide by negative 1. So you get y equals x minus 7. Right, the same thing as just switching all the signs. Divided by negative 1. So that's our graph. So we're going to start at negative 7. My slope is 1 over 1, right? Slope of 1 when you don't see the 1 in front. So I'm going to go up 1, right 1. So 1, right 1, a 1, right 1, a 1, right 1. Now, if I would have done this correctly, I believe they cross right here. My graph might be a little bit off. But negative, whoops, x first. 3, negative 4. That was embarrassing. So they cross at 3, negative 4. And you can always check your work if you want. Plug in 3 negative, substitute back into your equation. Like if I did this here, right? 3 minus negative 4, so that'll be a plus 4, you get 7. Okay. Couple more, right, where I gotta put it in slope-intercept form. So let's do this one. I just do this one, then move on. So let's try to get the y by itself. So I'm a minus x from both sides. We get negative 2y equals negative x minus 2. Right, I subtracted that x from both sides. So it's canceled out, and you have this. Now we want to get rid of that negative 2, so we have to divide everything by negative 2. So everything gets divided by negative 2. So we get y is equal to 2 negatives make a positive. This is 1/2 x. And then again, 2 negatives make a positive. I get plus 1. So that's my equation for this guy. So, right, trying to get y by itself. Subtract the x from both sides, divide by negative 2. So I'm going to start at 1. That's my y-intercept. My slope is 1/2, so we're going to go up 1, right 2. So up 1, right 2, right there. Like that. Okay, then we're going to graph this one. So my y-intercept here is negative 2, and my slope is 1/2. So negative 2, my slope is 1/2. I'm going to go up 1, right 2. And if you notice, these guys have the same slope. Both have a slope of 1/2. So they are parallel and they're never going to cross. So this is no solution. Right, because they're parallel lines. I can tell right here when they have the same slope. Oh, same slope, never going to cross. Okay, let's try this one real quick. So I'm going to get y by itself. So that's minus 2x from both sides. So I get y equals negative 2x plus 4. And that's pretty much it. So plus 4. Slope of negative 2 over 1. Right, that's my slope, that guy right there. So we're going to go down to right 1. And we're going to get this guy right here. Like that. Okay, next one. Again, I want to get y by itself, so it's minus the x from both sides. 1/2 y equals negative x plus 2. So right here we have a 1/2, I should say. Remember, the way you get rid of a fraction is multiply by the reciprocal. So let's multiply everything by 2. Times it by 2. So the product. So these would cancel out, and I would get y equals negative 2x plus 4. And if you notice, that's the exact same line. So this one, you get the exact same graph. So that means that there's infinitely many solutions because it's the exact same line. So same line. So infinitely many solutions. Okay, let's move on. So this is our last one. It's an application problem. Monisha and Holly are both reading a novel that is 220 pages long. Monisha has read 96 pages and plans on reading 9 pages per day. Holly has read 6 pages and plans on reading 20 pages per day. Write a system equation that models the situation. Okay, so we know how to do this. Let's write an equation for each of them. So for Monisha, right, we're going to do y equals mx plus b. Remember, b is our y-intercept, that's our starting value, our initial value. And m is our slope, the per. the rate. How fast are we going? Manisha has already read 96 pages and plans on reading 90 pages each day, so per day. So this is going to be my slope. That's our rate. We're going, how fast are we going? We're going 90 pages per day, but we're starting at 96. So for Manisha, our equation is 9x plus 96. Likewise for Holly, she's read 6 pages and plans on reading 20 pages per day because she has to catch up. So Holly is doing 20 pages per day, and she's read 6 pages so far. So those are 2 equations, and they want to know when will Holly catch up with Monisha. So one of these guys to be equal. So we're going to do this by graphing. Now this guy, if you notice, are pretty big. So this is actually one good example of one where you would not want to use it, not want to graph this by hand, because you have to go to 96 and have a slope of 9. That's to go to 6 and have a slope of 20. That's pretty big. So this is something you probably do on like Desmos or a graphing calculator, right? Because these are big numbers. So just to show you, let me show you the gist of it. So 96, let's just say it's 96 and a slope of 9. So it'd be something to this effect. And then Holly starts at 6, but she's going 90. Her slope is much faster. So it'd be something to that effect. And then right here where they cross is when they catch up. It's when Holly catches up. Now, if you do this on Desmos or on graphic calculator, you should get about 8.182, comma 169.636. So let's talk about what those 2 things mean, right? So remember, X is number of days. So it's gonna take her about 8 days to catch up to Holly. And then number of pages read, so it's made about 170 pages. So they're gonna meet at page 170. That's how I interpret it. Let's write that down though. So it will take Holly about 8 days to catch up to Monisha. And they will meet and she'll catch up on page 170. Now, a little bonus here. When will Monisha finish the novel? So how would we do that? Well, Monisha is this equation, right? And we know how long the novel is. The novel is 220 pages long. So where do I plug that in at? Do I plug that in for X or do we plug that in for Y? 220 pages? This is the Y value, right? That's what it says right here. It's pages read. So we're going to plug 220 in for the Y here. So it's going to be like this. 220 equals her equation, which is 9x plus 96. And all we have to do here is solve it. So minus 96 from both sides. So you get 9x is equal to 124. Then we can divide by 9. And we get x is approximately 13.8 days. Remember, x is days. So it's going to take about 2 weeks to finish the book. If we want to do the same thing for Holly, we could do the same thing for Holly, right? Holly has the same idea. The length of the book is the same, 220. But her equation is 20x plus 6. So let's figure out hers. Minus 6 from both sides. So I get 214 equals 20x. Divide by 20. We get x equals about 10.7. So it's going to take Holly about 11 days to finish. So she starts slower, but she's going at a faster rate. Anyway, that's the video.